These were the exam questions that I sent out in a slide deck a little bit earlier as we kind of work through them. Ideally, you've already spent some time looking at them, doing them, and then can, if we miss something along the way, can identify in your own notes where you missed it or made a mistake or something along those lines. That is going to be most valuable in prepping for the exam, is knowing where you tend to make mistakes, then doing things to fix those mistakes. As you also prep for the exam, remember that you need to be in the room by the time the exam starts. No latecomers. You can have a full sheet of paper front and back with anything you need on it, formulas, etc. So if you don't have even if you do have it memorized, I'd still write down the quadratic formula. Show some examples, possibly things like not just a problem, but then explanations. So if you struggle with completing the square, doing a problem that's completing the square that includes then a line describing what you did from step to step to step in that process. Yep, you'll need to have a calculator, no phones, no watches. And it needs to be able to do logarithms. So that's what you have to be thinking about. So either find a friend who doesn't need their calculator, order one today from Amazon for like $7.99 probably, have it delivered to your dorm room. I think the Student Study Center even loans them out. I think last semester I had someone show up and they ran out quick and came back and they'd had one from the Student Study Center, or Student Success Center, whatever. It's a 3-letter acronym. So here we go. Starting way back, and again, this may be like, oh wow, yeah, I totally remember how to do this. Shaped like a rectangle. So when you're doing this, trying to think, can I make a shape? Drawing pictures is very helpful when trying to work through problems, where it says the length is about 1.3 times its width, which means if I know the width, the length is 1.3 times the width. All right. And then it says perimeter. Vocab words, same kind of stuff. If you want to put vocab words on your sheet of paper, that's fine too if you struggle remembering perimeter versus area. So perimeter is the distance around. So if I were to walk from one corner and walk and trace my path all the way around that rectangle, that's my perimeter. And my perimeter is 2,070 kilometers. Which means it's a width plus a width plus a 1.3 W plus a 1.3 W. Adding all those lengths up gives me the full perimeter, and that should equal 2070. So now I have 1, 2, 3.3, 4.6 W's. Just in adding like terms there. And then solve for W. W equals 450. And that means the length, didn't mean to go, the length is 1.3 W, so 1.3 times that. 585. And then it wouldn't be a bad idea just to check those numbers quick. Do 585 plus 585 plus 450 plus 450 to see if you actually get a total distance around of 2070. Ooh. All right. Moving on now, solving. Solving processes are first simplify and then move variables around. All right, so simplifying first, a couple ways to go about this. I'm not a fan of fractions in having to deal with them all the way throughout. So what I'll typically do is I'll multiply everything by the common denominator. And the common denominator is 7. So when I do that, I'll have 21/7 times x minus 4 greater than or equal to 7x plus 14. And some people might wonder, how come I didn't multiply this by the 7? I did, but when I'm doing it, I'm multiplying 7 times 3/7 times x minus 4. This is all one term, so it only gets multiplied by the 7. These are two different terms because they're not in parentheses. That's why I multiplied them individually. 21/7 is 3. X minus 4 greater than or equal to 7x plus 14. 3x minus 12, distributive property, greater than or equal to 7x plus 14. And then, that's when I would start to then move my variables to one side, numbers to the other. There is an easier way. The easier way, so that you don't make a mistake later, is to move it to the side that has more on it. There's more x's over here. So my process will be to subtract 3x from both sides. That'll move my x's to the right-hand side. And if I'm going to do that, then I'm going to subtract 14 from both sides. Again, noticing that whatever I'm doing here, I have the exact same thing on the other side of my, in this case, inequality. Sometimes it's an equality. On the left, I have negative 26 greater than or equal to 4x. It's a negative. Then divide by 4. I will have, well, I can, yeah. And honestly, at that point, I would be okay. If you feel uncomfortable and think you have to reduce, you can. If you want to write it in the other direction, you can do that too. Just make sure that the x is at the pointy end, because that's where I had it. It's at the less than side. And then that would be negative 13/2. Is negative 2, 3 a solution for that equation? This is a matter of substituting it in. Put that in for x and that in for y. 3 times negative 2 plus 2 times 3. Does that equal 0? That's what we're trying to find out. Negative 6 plus 6 equals 0. Yes. Negative 2, 3 is a solution. Solving systems of equations. Either substitution method. On the exam, I'm not going to tell you which type. I'm not going to say, like we did earlier, I think on the first exam I said solve this one by substitution, solve this one by linear combinations. I'm never going to ask you to solve it by graphing, because that's the most labor intensive and you tend to get close to wrong answers all the time. Unless you have a graphing calculator, then you can do it. So in this case, it's a matter of, do you want to do substitution or linear combinations? Being that they're already written as x's and y's, I'm going to do linear combinations. And I'm looking and I see this is a negative. So I want to make this a positive 3y, because then when I add them up, the y's will add to 0. So I'm going to multiply this side by 3. And when I do that, I will have 3x plus 3y equals negative 9. Add those two equations up. 2x and 3x is 5x. Negative 3y, positive 3y adds to 0. Over here it'll add to 10. X equals 2. But I'm not done. Need to put that up there. 2 plus y equals negative 3. Y equals negative 5. So my final answer is the point 2 comma negative 5. Just like we had on that last slide, is it a solution of the one equation? Here we found a solution that works for both equations. And they also happen to intersect. If they don't intersect, if I had two lines that were parallel, pretend that these are parallel lines, we'll mark them as parallel. All right, if that were to happen, I would end up with something like 5 equals 2. Or something equals 0 that's not 0. If that's the case, what you're really saying is, well, when does 5 equal 2? And the answer is never. Well, that means they never intersect. If I do a problem where I end up with something like 2 equals 2, what does that mean? That means the first line was like this, and then the second line was exactly on top of that line. Because again, we're saying, when does 2 equal 2? Always. 2 is always equal to 2, which means these two lines will always intersect. So my three choices are they intersect at one point. Up here, they never intersect. And then over here, they intersect at every point. Simplify. Remember, simplify means you're not going to have an answer. I've seen this way too many times in my career. At the end, someone's going to be like, x equals something. You can't do that because there is no equal sign. Simplify just means combining like terms if I have them. In this case, it's going to be, what am I doing with exponents? But I'm going to start by rewriting it just because my brackets look kind of weird. Over x squared. And it's everything to the minus 2 power. All right. Parentheses is still where I would start. Do what's inside parentheses first. So I'm going to have 5x to the minus 3 minus 2. I have same bases. Also make note, that is only on the x. How do I know it's only on the x? Because there's no parentheses around it. An exponent goes on whatever it's adjacent to. But if there's a parenthesis, then it's to everything inside, like the negative 2 is, and we'll get to that in a second. So same bases, they both have x. And again, I'm only multiplying here. 5 times x to the negative third divided by x squared. I'm multiplying and dividing. So that's why I can combine these two. And when I divide by same bases, I subtract exponents. Negative 3 minus 2. And then the whole thing is still to the negative 2. So I'm going to combine inside. I'm going to have 5x to the negative 5. All to the negative 2. Now, I have powers raised to powers. And I'm only multiplying. It's now not a bad idea to remember that 5 is the same as saying 5 to the first power. So when I bring the exponent in, I'm doing exponents times exponents because it's powers raised to powers. Powers raised to powers, so all 5 to the negative 2 because it's 1 times negative 2 times x to the, now it's positive 10, negative 5 times negative 2. Last step, x to the 10th over 5 squared. The negative means it goes to the other side of the fraction bar. And if I'm in the numerator, it goes to the denominator. If the negative is in the denominator, then the whole thing moves to the numerator and stays positive at that point. And if you make that 25, you can. I would be comfortable just with this as a solution. All right, now we get to solve. So in solving, I'm going to have an answer at the very end. And I've got this massive, ugly looking fraction. Starting with what, and again, this is going with a process for solving when I have these complicated things, is I usually want to start by factoring, which it might not make sense. Ooh, come on now. There we go. Factor. Then we're going to simplify. And then we're going to solve. So the first one, there's nothing here that can factor, because x minus 3 is just itself. This cannot factor, but this can. And it should look very, 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 very familiar. X plus 3, x minus 3. It's a difference of squares. So now I look at my denominator and say, okay, now can I simplify? I have fractions. If I have a whole bunch of fractions, I either want to add some fractions or subtract the fractions, or in my case, I want to get rid of fractions. And the way to do it, like I did on that other one, where I multiplied by 7, is I want to multiply by the common denominator. The common denominator will be x plus 3 times x minus 3. Which means this first one up here, the 1 over x minus 3, I need to multiply it by x plus 3 over x plus 3. Remember, x plus 3 over x plus 3 is just the value of 1. Anything divided by itself is 1. So I'm multiplying this by 1, which again, it doesn't make the problem, or it doesn't change the value of that fraction, just changes how it looks. All right, then I'm going to have over here plus, I'll have 2 over x plus 3. I wanted to make that yellow. 2 over x plus 3. And that one needs to be multiplied by x minus 3 over x minus 3. So again, now that this denominator is x plus 3, x minus 3, this one's also x plus 3, x minus 3. And then the last one over here, I'm going to multiply it by x. Actually, I don't have to multiply it by anything. It already has the full denominator. 1 over x plus 3, x minus 3. So then I'll have, in this fraction, 1 times what's in the numerator, plus 2 times x minus 3, right here, 2 times x minus 3. The denominator will be the full thing. Equals 1 over x plus 3, x minus 3. So now I have this massive looking fraction thing, and you might think, how is this any better? I now have all of them with the same denominator, which means these two fractions can now add. X plus 3 plus 2 times x minus 3 equals 1. And since they're all over the same denominator, that means the numerators have to be equal to each other as well. At which point, so then I'm eliminating the denominator. They're all over the same thing, so I don't have to write the denominator anymore. At the end, though, I'm going to have to go back and look at my equation and remember that things like I can't have 3 as an answer. Because if I do 3 minus 3, I have 0 in the denominator, and that's impossible. I cannot have negative 3 as an answer, because negative 3 plus 3 is 0. So at the end, if I end up with one of those two as my answer, I'll have to go back and say, well, technically it solves that way. I can't use it. X plus 3 plus 2x minus 6 equals 1. 3x minus 3 equals 1. 3x equals 4. X equals 4/3. Again, assuming that I paid attention, kept track of my negative signs. 3 and negative 6 is negative 3. That all looks right. That's my solution. I could always go back and check in the original equation to see if it works, if you're really worried. But again, checking all my steps, working through that process. Or not. Factor. All right, factoring is splitting it up. It's the opposite of simplifying. So factor it out. Looking for, first thing, is there a GCF? Are all 3 of these divisible by the same number? No, they're not. That makes it harder. So then, if there's no GCF, then I'm going to take, and we're going to really jog our memory, factor by grouping. A times C will be 28 times negative 10, which is negative 280. I need to think of factors, two things that multiply to negative 280 that might add to negative 27. So one's positive and one is negative. Now the two factors that we just did, and just so we know. So this is negative, which means whatever I have over here, the larger of the two numbers, going to have to be negative because it has to add to negative 27. So if I start with what I just had, if I do negative 28 and 10, those add up to negative 18. So I need two numbers that are further apart. So go ahead and grab your calculator, start thinking of two numbers that multiply to 280 and see if you can come up with a pair that adds to negative 27. I'll put up a couple that I know won't work. Negative 56 and 5. Negative 56 and 5 multiply to negative 280, but they definitely do not add to negative 27. Negative what? 35 and 8. Negative 35 and 8. So 35 times 8 multiplies to 280. 35 minus 8, or negative 35 plus 8, adds to negative 27. So this is the pair that I'm going to do by factor by grouping. So what I'm going to do is take this down here, 28x squared, and I'm going to rewrite the negative 27x as negative 35x plus 8x. So again, I took this and I split it into those two values because they'll add to negative 27. So again, we're unsimplifying this, breaking it apart, minus 10. Now I'm going to look, when I say factor by grouping, I've got this group and I have this group. Well, I can see right away, this is my easier one. 8x and negative 10 are both divisible by 2. So it'd be plus 2 times 4x minus 5. 28 and 35, x squared and x, they're both going to have an x coming out of it. (28) and 35 are divisible by 7. So this will be 4x minus 5. 35 divided by 7, 28 divided by 7. And again, if we're doing factor by grouping and I found a pair, this should happen, that they're the same thing. So now I have two things multiplied, and one of those things, this and this are identical, which means they can factor out in front. So out in front comes the 4x minus 5. And when I do that, I'm left with 7x plus 2. And then the last thing would be to look, is there anything else I could factor out of either one of those? And the answer is no. 7 and 2 are piecewise prime, so are 4 and negative 5. So that would be how I would factor this. Now, although not the question, what if this equaled 0? Well, that means I either have to have 0 times something or something times 0 to get 0. 4x minus 5 equals 0, or 7x plus 2 equals 0. I'd have two equations I'd have to solve. and you'd have two solutions to a quadratic. Take a moment in your seats, on your piece of paper, factor those four. And this should not be a long process. I recognize a pattern. We've seen this before. Professor, you have said it so many times. I'm kind of sick and tired of you talking about it all the time. The fourth one will have an extra step before you get to the pattern. But the top three all follow the same pattern. Mathematics, the study of patterns. All right, what's that first one factor to? Absolutely, well done. How about that second one? Absolutely. Gets a little trickier. Oop, yep, sorry. 2x plus 5y, yes, and 2x minus 5y. Well done. Now, got to do a step first, and then we can do the final factoring. What's the first step? Greatest common factor. What is the largest number that goes into both 8 and 50? 2. X cubed and x. Well, they both have a variable. What's the largest x I can remove from both of them? Just x. Then I'll have x squared. Sorry, 4x squared minus 25, which looks a lot like the one we just finished. So it'll be 2x and then 2x plus 5, 2x minus 5. So if you did not see the difference of squares right away, that's something you should probably write down on your sheet of paper as a reminder to yourself. Write down a couple examples. If I were you, I don't write down this as an example, or even that one. Those are the quote-unquote easier ones. Something more like this, where it's a little atypical. Solve. Take a moment. Find my 3 answers. See if you can figure that out. Again, if you recognize it right away, it's fast. If you don't, it'll take you a couple steps. All right, what's one answer, and tell me how you know? X equals 4. Tell me how you know. Because 4 minus 4 is 0, so I'll have 0 times whatever this is times whatever that is, because there's 3 things that are being multiplied. And if they multiply to 0, one of them's got to be 0. What's another answer? Yep. 3/8. How do you know?
Because in the second one, if you put ax minus 3 equals 0.
The third one?
Yeah. Sorry, the third one, yeah. You add 3 and divide by 8.
All right. And final answer?
0.
0. Because 5 times what number is 0? All right. 5x equals 0, same kind of thing. X equals 0 over 5, which is 0. 3 answers. So now, take a moment with who you're ever seated by, or on your own. See if you can solve that one using the processes we've talked about. On your marks, get set, go. Or just start. There's not a greatest common factor. It's not a difference of squares. The first coefficient isn't 1, which makes it harder. So no GCF. So then I'm going to do A times C, which is negative 70. Then try to find 2 numbers that multiply to negative 70 that add to positive 3. Ten and negative 7 multiply to negative 70. They add to positive 3. Factor by grouping. 2x squared. Now what I'm going to do, if one of these is negative, a little pro tip, put the negative one first. If they're both negative, well then it doesn't matter. And the reason why is because if this were negative, I'd have to make sure I factored a negative out of the first term so that it would be plus and plus. But either way, there's my group, there's my group. Factoring. I will have x times 2x minus 7 plus common factor here, 5. 10, that's 2x minus 7. And once again, if I've done factoring by grouping the right way, pick 2 numbers, they're the right numbers because they add to the middle term, I will find out that whatever I have in parentheses is the same. So if I factor 2x minus 7 from each of them, again, what we're thinking of is dividing. That's what factoring is. I'm left with x plus 5, and this whole thing equals 0. X equals negative 5. And x equals 7 over 2. Because again, just took this 2x plus minus 7, set it equal to 0. Add 7, 2x equals 7, divide by 2. Again, more fractions, more complication, fractions within fractions. First thing first, think about it like two separate parts first. I'm going to do x plus 2 over x. Can that be simplified? Not easily. So I'm going to leave it there for a second. On the right, on the denominator, I have x minus 4 over x. Well, I've got this weird fraction, and I need to be able to combine those together to simplify. In order to do that, they need the same denominator. This has a denominator of 1. I need the both to be a denominator of x. So to do that, I'll multiply this by x over x. Because x over x is 1, I'll have x squared over x minus 4 over x. And that can combine to x squared minus 4 over x. So my denominator, when combined together into a single fraction, is x squared minus 4 over x. With the original problem, that's how I rewrite it. So I've got this in the numerator. I have this in the denominator. After we have our numerator and denominator as single fractions, then I can remember the rule that says when you divide by a fraction, that is the same thing as multiplying by the reciprocal. X plus 2 over x times x over x squared minus 4. Go ahead and put these in parentheses. When I'm multiplying, I can multiply fractions straight across. I'll have x times x plus 2. I just rearrange those two. In the denominator, x times x squared minus 4. X over x is 1. And then, because we've done it like a bazillion times, I see x squared minus 4, and my instinct is, oh my gosh, that's x plus 2, x minus 2. I can think of that in the numerator as having parentheses because it's the whole thing being divided, but now, x, that's the same thing. And I rewrote, that should be a 2 right there. For a final answer of 1 over x minus 2. Ta-da! So procedurally, if it's a complex fraction like that, get your numerator as its own fraction, get the denominator as its own fraction, and then recalling that when I divide by a fraction, it's the same as multiplying by the reciprocal of the denominator. Every once in a while, I'll see people try to flip the numerator. Numerator stays as is. It's the denominator that flips. And if you still struggle with that rule, it's no different than if I have like 8 divided by 2 is the same as 8 times 1/2. 2 as a fraction is 2 over 1. So its reciprocal is 1/2. So dividing by 2 is the same as multiplying by 1/2. Dividing by this is multiplying by the reciprocal of that. The fastest way to do this is synthetic division. You can do long division otherwise. And I'll go ahead and show the long division first, only because it's a little bit more labor, and hopefully then at the end you're like, okay, yeah, synthetic was way easier. Long division, it's like this. Write the whole thing. 2x cubed minus x squared minus 8x minus 1. And I'm always thinking x into 2x cubed is 2x squared. That is, x times what gives me 2x cubed? So then I take 2x squared times x is 2x cubed. 2x squared times negative 2 is negative 4x squared. Subtracting. 2x cubed minus 2x cubed is 0. Negative x squared minus a negative. See, this is where it gets harder with long division, is remembering all these negatives and we're subtracting. So negative x squared minus negative 4x squared. Well, minus a negative is plus a positive. So this is 3x squared. Bring down the negative 8x. And I'm saying x times what is 3x squared? 3x. 3x times x, 3x squared. 3x times negative 2, negative 6x. Subtracting. 3x squared minus 3x squared is 0. Negative 8 minus a negative. Well, minus a negative is plus a positive. So negative 8 plus 6 is negative 2x. Bring down the minus 1. X times what gives me negative 2x? That will be negative 2. Negative 2 times x down here. Then negative 2 times negative 2. So I'll have negative 2x and plus 4. Subtracting. Negative 2x positive and negative 2x minus a negative. Minus a negative is plus a positive. That adds to 0. Negative 1 minus 4 is negative 5. So my final answer would be, move it over here, there we go, 2x squared plus 3x minus 2 minus 5 over x minus 2. That's what I do with that denominator, or with the remainder, I mean. It's negative 5, so it's negative 5 over whatever I was dividing by. Synthetic division, 2, negative 1, negative 8, negative 1. I only write the coefficients. 2, negative 1, negative 8, negative 1. The number I'm using is not negative 2, it's what makes this 0. And again, because regular division is subtracting, synthetic division uses adding. So instead of whatever the actual this number is, I say, well, what makes it 0? That's my 2. First thing I do is I bring down the 2. And then it's 2 times 2, and that goes here, and that's 4. Then I add. 2 times 3, and that goes here, and that's 6. And I'm adding negative 2. 2 times negative 2 goes here. That's negative 4. And I'm adding negative 5. My highest power here was x cubed, so this one is x squared. So it will be 2x squared. That 3 is positive, so plus 3x. The next number is negative, so minus 2. And then minus 5 over x minus 2, which is the same answer. A lot fewer steps. I like the fact that it's addition. You've seen me lecture and heard me talk so many times. I lose track of negatives constantly. This helps me. When solving, when there is a square root involved, the process is, first step, if possible, get the square root all by itself on one side of the equation and have everything else on the other side. A mistake I see people make is they will just, so I'm going to write this down, but don't write this down. People are like, well, I'm just going to square everything. And then they say it's x squared minus x plus 1 minus 25 or something like that. Squaring can only be done when I'm multiplying. These are being added and subtracted, which means this is bad math. So I'm not going to do that. Instead, try to get the square root all by itself on one side. So to do that, I'm going to add the square root of x plus 1 over here. And on this side, I'm going to add the square root of x plus 1. Because they're equal, whatever you do on one side, you do the other side of an equation. I'm left with x minus 5 equals square root of x plus 1. Now I can square the right side because the entire right side is square rooted. So if I square the right side, and then I have to square this side, again, working with an equation, if I do a math operation to one side, I have to do the same thing to the other side. Square root of something squared is x plus 1. They're inverse operations. But only if it's only a square root on that side, which is why we couldn't do it up here to start with. There was more than a square root. I had two other terms, 3 terms total. Over here, I have x minus 5 squared, which is x minus 5 times x minus 5. The mistake I'll see here often is people will say, well, that's x squared minus 25, which is not true. What you're missing is you're missing the outside and inside terms when you FOIL. X squared, I'll have minus 5x and minus 5x for minus 10x, then plus 25 equals x plus 1. And now I'm looking like a quadratic again. Solving quadratics, set them equal to 0. Subtract x and subtract 1 from both sides. X squared minus 11x plus 24 equals 0. Now I'm thinking, are there two numbers? Since the first coefficient is 1, then I can factor it this way. Two numbers that multiply to 24, add to negative 11. Negative 8 and negative 3. Well, 8 and 3 is 11, but since the middle term is negative, they have to both add to negative. Since the last term is positive, they're both the same signs. If the last term is positive, then these are either both positive or both negative. The middle number tells you which. They're both negative. Then finally, x equals 3, x equals 8. Because they will make, 8 will make that 0, 3 will make that 0. How do we find inverse functions? Yep, that's f to the negative 1 of x is how we write the word inverse. But how do we find it? And I need to find the inverse of this function. Yep, then what? Correct, x equals 3y. So to find the inverse, you rewrite the f of x as y, and then flip-flop the x and the y. And now we need to solve for y. Add 5 to both sides. Yes?
For the first part in yellow, when you do the
All right, and then last thing, I'll have x plus 5 over 3 equals y. What does that look like? So g of x is the same thing as the inverse of f of x. The other way I knew that it was is if I ever take a composite of inverse functions, they will always equal x. So if I take f of inverse of f of x, it equals x. I don't even have to know what the equation is. If I add an arbitrary third one, if I take h of the inverse of h of x, it's also going to just equal x. Composite functions of inverse functions will simplify to x, period. That's just unique quality of the inverse function. Logarithms. If you don't remember, it would be wise to somehow set it up so that you can remember how this all works. Words like this is the base. This is the exponent. When converting from logarithm to exponential form, so it's 5 to the third power. And then, again, I'm going here to there, and then back across, equals x. That's not a math equation. That's not anything other than this is how a logarithm is defined. A logarithm is defined as an exponent. X equals 125. But whatever's inside of the logarithm is on the, it's basically what it equals. It's what the exponent side equals. So this is the exponent side. It's going to equal whatever inside that parenthesis set for a logarithm. Going the other direction, if I have this, and I have it as exponential form, well, here I'm even telling you. First, convert this exponential form into logarithmic form. So there's three things. What's my base? 10. What's my exponent? 3x minus 2. And what is it equals? 0.01. So as logarithmic form, it's going to be log base 10, because that's what the base is, of 0.01 equals 3x minus 2. Because like I had on the other page, log base b of a equals x. In the logarithm, that's the exponent. This was the exponent. What this whole thing equals is what's inside the logarithm, and then this tells me the base number. Now, if you do this in your calculator, because your calculator has log base 10, you'll find that that is the number negative 2 equals 3x minus 2. Add 2 to both sides. 0 equals 3x. X equals 0. And you could try that. Put it back up in here. If x equals 0, I'll have 10 to the 3 times 0 minus 2. So that's going to be 3 to the 0 minus 2, negative 2. 10. 10 to the negative 2. And then in your calculator, 10 to the negative 2 is 0.01, which is what it was supposed to equal. A fun extension of this is making this a quadratic. So first you're converting out of exponential into logarithmic. You're finding a number, and then you're going to end up with a quadratic, and then you're going to have to do factoring of a quadratic. That's why, one problem can cover many, many, many concepts all together in one. Simplify. There shouldn't be an equal sign here, because simplify, there are no equal signs. So simplify is, can I combine them in any ways? They all have the same base, so it's remembering the properties of logarithms. All right, there's a little blue or green box in your textbook. It's on the left-hand side, lower side of the page, probably like 9.3, somewhere in that range, where it talks about all the things you do. So when I'm adding same bases, they can combine by multiplying. Now, I wrote plus 18 times 2 minus log base 3 of 9. All right. Now I have same bases, and I'm subtracting. They can combine log base 3 of 18 times 2 divided by 9. Adding same base logs, I multiply what's inside. Subtracting same base logs is dividing. And then lastly, this will be log base 3. Let's see. I can do some reducing here. 18 and that, so this is 2. So log base 3 of 4. That's it. Your calculator does not have a base of 3, so you're not going to be finding out what that is as a decimal. There is a way you could find that on your calculator. I won't be asking it on the exam, but if you're taking pre-calc next term, you would change that. That's equal to log base 4 divided by log of 4 divided by log of 3, where they're both base 10. That you can do in your calculator. I'd take log of 4, then divided by log 3, enter. It would tell me the decimal value for that. But we don't have to. We'll end right here. So with that in mind, I want you to try this. You're going to combine them together using the properties of logarithms. Then you're going to convert it to exponential form. So if you already did this problem because I sent them out earlier, great. Look at what you did, see how it compares. If you haven't, do that now. So if you did not work on these before coming to class, my recommendation would be to get that slide deck out that I sent you as a PDF attachment and work on all those problems again, but from memory. You'll have a resource up till this point of all the ones that we've already completed. There's a few left on this slide deck and then a couple other follow-up questions I'll have for our next gathering. So the final audio of this and video will not get posted until after class on Thursday. All right. And then the test is on Tuesday next week. 8 a.m. in this room. You're here by 8, no later than 8. Full sheet of paper if you want it that you'll turn in, but on the front and back, formulas, example problems, properties, principles, anything along those lines. And then make sure you have a calculator that can do logarithms and exponents. We'll have 2 hours designated for the test. It probably won't take you the full 2. But you'll have the full 2 if you just need the time. So like I said, when a problem like this exists where it's same bases and there's 2 different ones of the logs, whether it's going to be plus or minus or whatever's going on here, what you have to remember is that you got to combine them first and then convert it into exponential. So here we did using the properties of logarithms, and then here we're going to then convert it. So that's what we did before we came back, so I can finish out this video and this class and everything else, but that's the base. When it's written as a logarithm, whatever the logarithm equals, when it's just one logarithm, that's the exponent. That's why we got to get it to one logarithm first. So we get it to one logarithm first, and then the base, that becomes the exponent, and then it equals the stuff in the middle. So when I did it here, I went 2, you can see in that bottom next, to the first power equals the stuff that's inside the logarithm. 2 equals this. And then this now I'm going to distributive property x squared minus x, and then recognize that's going to be a quadratic. So 0 equals that, and then factoring. And then what makes it 0? 2 makes this 0, -1 makes that 0 for my 2 solutions. So, moving on, if this were the scenario, write something down to yourself, talk to the person you're sitting next to, because this would have been one of the last 2 lectures we did. We did one that involved permutations and combinations, and this is one of them. The other one we did involved conic sections, which will be another slide here in a little bit. So take a moment, see if you can remember how to do this. Even if you had to do it longhand, how would you have to do it? So when I come back, we'll go through 2 different ways to solve that one. No, what type of a scenario is this? The 2 we talked about were combination and permutation. It's a permutation. How do we know it's a permutation? Well, it was a 50-50 shot. You got the right one. What does it mean to be a permutation?
Like a form of like a probability.
Well, it gets used for probability for sure. Yep. All right. The distinction between the 2, remember the thing that you dialed? You did the dial and you put in your locker.
Oh, okay.
Combination, but we said that was wrong because it should be a locker permutation because the order matters. So in a permutation, the words you're thinking of, order matters. If you've ever been in a race, is there a difference between first and fifth?
Yes.
Yeah, so the order matters. If you're just being put into groups of people, like, we assign you to random groups, does the order matter? No, you're just a group of 3. It doesn't matter if you're picked first, second, or third. You're just a randomly assigned group. So in a permutation, order matters. In a combination, order does not matter. All right. So if it's something like, if it's not a race, other examples would be, if you had like class officers, right? President, vice president, secretary, treasurer. Since those are each individual places in a way, that would also be a permutation because again, it would be different from being a president versus being the secretary. So this is a permutation because the order matters. So then the formula, which you're about to give me, was n factorial over, NPR, which is n things, permutation. I want r of them. And then the formula is n factorial over n minus r factorial. And factorial means you start with whatever number that is and then multiply all the way down to 1.
Oh, okay, so it'd be like 10 times 9 times 8 times 7.
Yeah, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. I'm not going to write times 1. It is there, but it doesn't really matter. Yeah, it's like redundant. It's the identity. And then down here, n minus r, that's going to be 10 minus 5, which is 5. So it's 5 factorial, which is 5 times 4 times 3 times 2 times 1. And then reduce the 3s, reduce the 4s, reduce the 5s, and then I'm just left with 9 times 8 times 7 times 6. All right. I said that was one way you could solve it. Ooh, didn't want to go up. There we go. Shrink it a little bit. The other way, when you're talking about like place finishers, I'm just going to go like this. I want first, second, third, fourth, fifth. So first, second, third, fourth, fifth. And then I think it's always, if you think of a race as happening, before they cross the finish line, how many people could be in first place?
1.
Well, there will only be one, but how many could be in first place?
5 or 10.
10. There's 10 different people who could be in first place.
Yeah.
Then the first place finisher crosses. How many people could be in second place?
9.
9,
Oh, okay.
8, 7, 6. All right. So, and then that, again, this is going to be a large number that you can calculate on your own. Did someone do that?
30,240.
30,000? What?
240.
240?
Yeah.
All right. That's a lot of different ways for 10 people to finish first through fifth.
Yeah.
Yep.
And then you divide it by the other number, right? 120.
Sorry. Is 10 times 9 times 8 times 7 times 6, is that 30,000 or is that the whole numerator?
That's 30,000. Or, well, I just.
So that's the total number of ways people could place first through fifth place if there's 10 people in a race or in a room or playing a game or something like that. What if, same 10 people, I just want a group of 5. All right, 10 people, group of 5. So this is now combination. And my formula there is NCR. Again, as you're thinking about what to have on that sheet of paper, probably good to have all these on there. N factorial divided by R factorial times N minus R factorial. So if you look at that formula, it looks a lot like the permutation. This is the only difference right there. I have this extra number right there. So when I'm doing this, if I've already done the first one, I can say, well, NCR equals 10 factorial over R is 5, so 5 factorial, and N minus R is also 5 factorial. But then, we just did it on the previous slide, 30,240 was the permutation, and the only thing different was this, right? Because this here just the n factorial over n minus r factorial. That's permutation. So then I just have to have r factorial in the denominator. Oh, but r we know is 5. So I'm going to divide that by 5 factorial. Now if I go back, I could have done it also. 10 times 9 times 8 times 7 times 6 times 5 factorial, because 5 factorial is 5, 4, 3, 2, 1. This 5 factorial I'm going to put right there, and they're going to reduce. This factorial right here, I'm going to write 5 times 4 times 3 times 2. And then I can reduce items here. 5 goes into 10 twice. 4 goes into 8 twice. 3 goes into 6 twice. This 2 goes into that 2 once, leaving me with 2, 9, 2, 7, and that's it. Which is 7 times 9 is 63 times 4. $252.
Yeah.
There are, and again, look at the difference there. When the order matters, there's 30,240 ways that they could finish first through fifth. If order doesn't matter, there's only 252 different ways to get a group of 5. It's a remarkably smaller number.
It's times 4.
All right. Ever heard airplanes talk about what their Mach speed is?
The speed of sound.
It's the speed of sound, yep. So Ernest Mach is the guy who came up with that. So Mach is measured in terms of like how many times the speed of sound a plane can travel. So the Concorde, which was a commercial jet, was the fastest commercial jet. And it had a maximum speed of 15,002.2 miles per hour, which is Mach 2.03. All right, so it's going 2 times the speed of sound. The SR-71 Blackbird is a retired military plane. Actually, interesting fact. On its retirement flight from Beale Air Force Base to DC, because that's where it's now stored, one of them is, it broke the record in its last flight. So, and it was a early 1970s airplane that flew into the mid-90s. I mean, it was some pretty advanced technology. But it is said to travel over 2,200 miles per hour. Well, it's faster. But what we're going to look at here is it says, what is the Mach speed of the Blackbird? The speed of an aircraft varies directly. There's my mathematical term. Varies directly. Because we had 2 different types of variation questions. We said they either vary directly or inversely. All right, directly or inversely. If it's a direct variation, which this one is because it says it varies directly, that means we had this generalized equation that was y equals some number k times x. So I look up at what am I given? I'm given the Concorde's information. I'm given the miles per hour. I need to use that to predict the Mach. So I'm given the x of 1520, or 1502.2. 1502.2 times some number k equals its Mach speed, which is 2.03. So again, first identifying it varies directly. Probably looking at your formula sheet to be like, oh, did I have the directly equation on there? Y equals kx. Or the inverse. Now this one's not inverse. But if it was, that equation is y equals k over x. Because inverse means as one goes up, the other one goes down. Directly means as one goes up, the other one goes up. As the speed goes up, so does its Mach.
It's not like you put it
All right, so then I said, all right, it's directly. I've picked my formula. I've plugged in the values it gave me. It gave me my 1x, because these connect to each other. Speed connects to Mach. I need to find the constant. What is my constant first? So I need to solve for k. Multiplying, so I divide 1502.2. 1502.2. And I'll find that k equals, how much?
740. Well, yeah, 740. I got 740, but I divided 1502.
Yeah, you did that. You gotta go 2.03 divided by the 1502.2. 0.000, oh no, just two zeros. 0.00135. It's actually 135135. But I'll leave it like that. So my equation, my full equation for this to make conversions is y equals 0.00135 times x. Now I can use
That to find the Mach speed.
that to find the Mach speed. That's my x of the Blackbird. So times 2200. So y equals 2.973. Almost 3 times the speed of sound for the SR-71 Blackbird. All right, and it said that it travels over that because I believe its top speed is still restricted classified information. It might be out there somewhere on the internet. But that's how you would set up and do a direct variation problem. Some people say, well, what if I set it up the other way? And what do I mean by that? If I set it up and said, well, I said that the 1502.2 equals k times 2.03. What if I put the x and a y in a different place? All right. Well, my k here would be 1502.2 divided by 2.03, which is 740. My equation would then be y equals 740x. All right. So in this case, this was the speed in miles per hour. Miles per hour. This was the Mach. So then I would put in 2200 equals 740x. And if you do 2200 divided by 740, we get 2.9723. Same thing. All right. They are both correct ways of doing this equation. So even if you're like, I don't know which one's x, I don't know which one's y, don't let that bother you. Just make one of them the x, the other one y, and then work through it. All right, so take some time, or if you have to, grab your book, look back in your notes. But again, approaching these problems like, if this were the exam, would I even know where to start with this? My hope would be yes. That you have an idea, or at least you can flip back through your notes to where we've gone through this in the past, and you can say, okay, here I think I found something about things that have a percent decrease or something that might have a percent increase. So give that a try. Ines, what's the formula?
A equals P times 1 plus R and X plus N.
There it is. A equals P times, parenthesis, 1 plus R to the N. What does A stand for? Amount at the end. Okay. P stands for principal, because this is usually talking about doing stuff that uses finances, so they usually talk about P. But principal is what you start with. So amount at the beginning. R is the,
That's the R is a percentage, right?
yep, that's the rate.
Yeah.
And we got to remember, if it's growth,
It's addition and it's
R is positive, yep. If it's decreasing or decay,
negative.
R is negative. And then N is,
The amount of weeks.
right, in this case, it's going to be the number of weeks. It might be number of years. It depends on what kind of a setup they have. It could be by the day, by the hour. Certain things decay super fast. So it'd be like it decays this much every hour. So you'd be like, okay, that's significant decay. When you talk about how things biodegrade, all right, a lot of them follow something like this, where it takes a long time for them to degrade, but at the end seems to go quicker just because there's less of it. But there you'd be talking years or decades or even centuries for some things as they decay, if they actually decay. So now we've got it figured out for formula, and now we got to put in numbers. Do we know the ending amount? No, that's what we're looking for. So that will be A. Do we know the principal, the starting amount? 285. Parenthesis 1 plus, do we know the rate?
0.08.
Yeah, make sure you switch it to percents. And is it going to be plus or minus?
Minus.
It'll be minus. So I need to change that plus back to a minus. It will be minus 0.08. Do I know N?
It's 13.
It's 13. And now we have to make sure that we do order of operations.
So, parentheses first.
Yep, do parentheses first. 0.9,
0.92.
2. All right. That's parentheses. Then I got to do my exponents. 0.92 to the 13th power. So again, this also reinforces the fact that you got to have a calculator for the exam. 0.33825. So A equals 285 times 0.33825. So I'll just take that number times 285. Equals 96.4. Well, can I have 0.4 of a student?
No.
No, 96.
96.
Actually, you could say 96 or 97 because in this case, rounding is really not that important. It's more talking an estimate. Yes, sir.
So
All right, I said we would get back to this. The conic sections, we had 4 that we talked about. We have a circle. We had an ellipse. We had a parabola. And we had a hyperbola. And I told you for the exam, what you would need to know is what is it, and can you explain why you know what it is? All right. We did more than this. We actually did like them completing the square, and we actually found the center of each of those, whether it was a circle, ellipse, or a hyperbola. For a parabola, we have to find the vertex, and that you will have to know how to do, which I think is my next slide. But for this case, as you're looking at those, at a glance, all right, there were some rules that we kind of went through on the day that we did this. You know, a circle has this, an ellipse has this, a parabola, none of these are parabola because they're both x squareds and y squareds. A parabola would have to have only an x squared. So I'd have like a y plus 2x squared equals 3. That would be a parabola. because the x is the only thing squared. The y is not. But on all these others, they have both an x squared and a y squared. Now with that, do you remember what the ways were to distinguish between them? And there was a slide that we did. We had several of them there. Are there any guesses? So here's a hint. Look at those three equations and figure out what's, they're pretty much all the same except for one thing gets changed in each of them. Take a look at that, see if you can remember what it is. Jot down to yourself what you think you would respond, even if you're not sure. And then we'll come back and talk about the whys. So give that a try first. All the x squared terms have a different coefficient. Which means that's probably going to be my distinguishing characteristic. All right? What you're looking at when doing any of these is if they're both squared, it's going to be either a circle, an ellipse, or a hyperbola. At that point, you want to look at the coefficients of the y and the coefficients of the x. If they are both positive or both negative, so basically if they're the same sign, it will be either a circle or an ellipse. If they are different, if the coefficient here is positive and this one's negative, or if this one's negative and this one's positive, it's a hyperbola. So what?
So if which is positive, it's a hyperbola?
If they are both positive or both negative, it's either an ellipse or a circle. If they're different signs, it's a hyperbola. Which means, if I were matching, that's a hyperbola. And what we're doing, you say, what is it? Well, it's a hyperbola. And how do I know? The x squared and the y squared are not the same sign. One's positive, one's negative. And when we're doing these, the hyperbola and the parabola are the two easiest ones to identify. Because a hyperbola, both x squared and y squared, one's positive, the other one's negative, hyperbola. Parabola, there's only one of them is squared. If the x is squared, then the y is not. Or if the y is squared, then the x is not. And that would make it a parabola. So then we have to go to these two and say, well, then which one's which? If you had to guess, which one would you say is the circle? Not saying it out loud, just in your heads, you're thinking, if I had to guess. And then looking at the equations, you'd say, and this is how I would know, based on what you see, so either these are both positives, here they're the same, here they're different. Well, that's the difference. One of them will determine circle, the other one determines ellipse. Which one is the most uniform? An ellipse or a circle? if you can't remember what everything looks like, hopefully you know. Circle is, do yellow. A circle with a center right there. An ellipse, it's kind of like an oval, has a center. The parabola we talked. I've done lots of work with parabolas. There's the vertex. Hyperbola, that's one I don't really have a lot of room here for it, but that would be, it's going to be like this and like this when you graph it. Or, I'll do one way over here on the left. This and this when you graph it. That's also a hyperbola. All right. If the coefficients are the same, it's a circle. Both positive and the same number, I'll have a circle. Both positive but different coefficients, that's an ellipse. So circle to here, ellipse down to here. But again, you need to explain what. So if I guess the right answer on the exam, do I get points? Only if you have an explanation for what you think you see happening, and it makes sense. Now, if you end up taking pre-calc next, you'll spend more time graphing these, discovering what are called the foci or the focus, if it's an individual one. Lots of calculations that go into that, a lot of completing the square. That's why we've done a lot of completing the square in this class, so that you can be ready for that. And then, once you do it, you'll start getting the hang of seeing why this means it's an ellipse, and the significance of what those numbers are for it being an ellipse. All right? You'll see this and say, the y squareds are bigger, which means this is going to go up and down oval instead of a side-to-side oval. But officially, it's called an ellipse. So for that circle, if I erase the sign, and if this was negative and this is negative, it's still a circle. Because they're the same. They're, again, what you're looking at, they are the exact same coefficient. The number, not just the value, 3 and 3, but it's also negative and negative. If I had the same value, but one of them was positive, so if I change this one here to positive, that would make this a hyperbola because they're not the same signs. One's positive, one's negative. But I'm going to go ahead and get it back to what it was before, which was a circle. And we'll make them both negative. So both x squared and y squared have the exact same coefficient. That makes it a circle. Both positive or both negative.
And then how do you tell the ellipse apart?
And then the ellipse is either, again, both positive or both negative,
That's what you're saying about.
but different numbers. That's a 3, that's a 1. Yeah. And if you're explaining on an exam and you can't think of the right words, circle it. Be like, well, this and this are the same. That makes it a circle. That would be fine. This and this are different, but both positive. Makes it an ellipse. Circle this number, different numbers and positive and negative, hyperbola. There's only one squared value. It's a parabola. So then with the parabola, we need to be able to find the vertex. So finding the vertex utilizes the process of completing the square. Procedurally, completing the square, first thing that we did was in this case, we're going to move the constant to the other side. So I'll have y plus 17 equals x squared minus 8x. The reason why is at the end, when all is said and done, my final, or you can even think about this, the standard form, y minus h equals a times x minus k squared. That's a parabola. I may have written this backwards. H comma k. This one's a k. I mean, it doesn't really matter. It's whatever goes with the k, and then this is an h. So the vertex would be h comma k. That's why we're doing it. So I want to have a y and something on the left, and then I got to complete the square with the x's because the x is the thing that's squared. Completing the square steps is I take half of b and square it. So in this case, b is -8. Half of -8 is -4. So inside the parentheses, this is -4. I'm going to square it, which is 16. I'm going to add 16 on this side of the equation. I'm going to add 16 on that side of the equation. So I still have a balanced equation. Over here, I'll have y plus 33 equals x squared minus 8x plus 16 be x minus 4 and x minus 4 equals y plus 33. Something times itself is squaring, so that's x minus 4 squared equals y plus 33. Now it's in this form. So I look at this. In the general form, if I would say y minus what number, k makes it 0. So if I put k in here, k minus k is 0. That's why k is the center. What makes this 0?
Minus 33.
-33. So then for this, the vertex, the y value is -33. Yep, and then the x value is whatever makes this 0. So that would be 4. So the vertex of my parabola would be right there. Process to solve. So I'll go to my next slide. So x squared minus 8x minus 17. 0 equals x squared minus 8x minus 17. So I use the completing the square to solve for x, or to find the vertex, but I can also use completing the square to find the answer. Like, when does this equal 0? Because right now we can look at that and we know that that cannot be factored. How do I know it can't be factored? This -17. The only two things that multiply to 17 are 1 and 17, and they clearly do not add up to -8. So I do the same process. I move the 17 to the other side. Then I'm going to take half of b and square it, which we did on the last slide. So it's going to be plus 16 and plus 16. I'll have 33 equals x minus 4 squared. So I skipped a couple steps here because we just did it on the last slide. Then I want to solve for x. Well, how do I do that? I got to get rid of the square. How do I get rid of square? It's square root. But whenever I take the square root of something squared, the square root of something squared, square root of something squared, it means on the left it'll be plus or minus. So I'll have plus or minus the square root of 33 equals x minus 4. Then to solve for x, I add 4 to both sides. 4 plus or minus the square root of 33 equals x. Those are my two answers. 4 plus the square root of 33, 4 minus the square root of 33. And graphically, we found the vertex. The vertex to this was at 4, -33. That was the vertex. And these are the two places that it crosses the x-axis. So if you actually did the square root of 33 in your calculator, which you would not have to do on the final exam, just get it to here. That's done. You can rewrite it like this, that's fine too. But don't put the square root in. I'd like you to be doing simplified radical form for your square roots. All right. And then one more here. 0 equals x squared minus 8x minus 17 with the quadratic formula. There's the quadratic formula. Again, unless you've memorized it and you're so confident you're never going to forget it, by all means, don't write it on your formula sheet. Otherwise, I'd have it on there. It's not a bad idea before just plugging in numbers to go up here and just write down what is a equals. A is the number in front of the x squared. So that's a 1. B is the number in front of the x. It's a negative 8. C is the last number. Negative 17. So x equals negative 8. A negative 8 plus a positive, so it'll be a positive 8. Plus or minus the square root of b squared, so negative 8 squared, minus 4 times a times c. Keep extending my square root because it goes over all, and it's all over 2a. Oh, we know a. A is 1. So 2 times 1. I'm just going to write it as 2. X equals 8 plus or minus the square root of negative 8 squared is 64. Be careful. Some of you on your calculators, if you put in negative 8, like on a graphing calculator, if you do negative 8 squared, it tells you the answer is negative 64. Is because the algorithm in your calculator does the squaring before making it negative. So if you have a graphing calculator, you'd have to do negative 8 caret squared or hit the squared button. That'll give you 64. Inside here I have negative times a negative. Forgot my other parentheses. A negative times a negative, so that will be positive. And 4 times 17. Is it 58? I think so. All over 2. Bless you. Equals 8 plus or minus the square root of 122. Or no, that's not right.
Professor.
Yes.
68.
68. Thank you. 132 over 2. Let's say I did something wrong because I got to here and I knew that that wasn't going to work with 122. So believe it or not, this is the same answer that we just did on the last slide. It just doesn't look the same yet. I need to now take this over here, square root of 132. Is there a number that goes into both of those where one of them I know the square root of? So you're thinking of all the numbers that you know the square roots of. 4, 9, 16, 25. Most people typically start with the lowest number, 4. 4 goes in there. How many times? 33 times. Square root of 4 is 2. And 33 is prime, so that one's done. So then this is rewritten as 8 plus or minus 2 times the square root of 33 all over 2. I'm going to split up my fraction. 8 over 2 plus or minus 2 root 33 over 2. reduce. My answer is 4 plus or minus the square root of 33, which is what we got when we did completing the square. In my experience, most people have spent a lot of time in their past math doing the quadratic formula, which is absolutely fine. That formula, though, comes from the process of completing the square. So if you know how to do completing the square, you're going to get to the same answer every time. And I find that people mistake and lose track of negatives a lot. There just seems to be a lot more area in calculating where you can make a simple mistake that then gives you a drastically different answer. And then completing the process, but completing the square does the same thing. All right, on the exam, I will probably tell you, actually I do tell you, for this one, use the quadratic formula. For this one, use completing the square or factoring. All right? So just pay attention to what you're asked to do and how to do it. If I just say factor this, then however you want to do it, go for it. So that'll be it for my scheduled review. For those that are here, we'll stick around and do any other Q&A that you have. But remember, our exam is Tuesday, except for the baseball players. So Tuesday at 8 a.m. till 10 a.m. Have a calculator. That has to do, you'll have to be able to do exponents, roots, and logs. All right? And you cannot use no phones or watches or anything like that. You can have one sheet,
Is it gonna be as long as the other exam?
front and back, with anything you want on it. I mean, really, if you go back through all these slides, you could work every one of these problems out as an example. All right? It must be your sheet of paper, not someone who made a really good one and you got a photocopy of it. It's your sheet of paper because there's value. The reason why I let you do this, there is value in going back and looking for all those formulas and ideas, writing them down, doing example processes. In your examples, if you have an example on your piece of paper, the better way to do it is to actually write words saying what you did in each step, because that outlines process. Because you'll get to the exam, you might look at it and go, I don't even know what I did here, because you just wrote something down. So explaining it to yourself, if you can explain it to yourself, more likely you're going to remember how to do it. If you can explain it to someone else, teach them, highly likely you're going to remember how to do something. And then when you teach for like 20 years, it's just comes so naturally. All right. The exam itself, when I take the exam, because I write all the questions and I walk away from it and I come back, and when I take the exam, I take the amount of time it took me and multiply it by 4, and I assume that's about how long it's going to take you. All right. 1, I know the questions I'm writing, so I know what I'm expecting. 2, I've been doing this forever, and I'm fast. But I also show all my work. That's what slows me down. All right. So with that said, I took this test, and it took me 20 minutes. So multiply that times 4, that's 80 minutes. Well, that's like an hour and a half. You have 2 hours, because some of us are just take a little more time, and we don't want to be rushed. So there will be plenty of time. There should be plenty of time if you know the content to have time to get it all done. All right, because I want you to be able to really articulate your understanding of what's going on, and that takes time.